Hello friends, welcome back to Online Math Solve. We have this beautiful question right here to solve. So this is x power root x is equal to 12. And so our job is just to simplify the equation and then find out the value of x that is actually going to satisfy the equation. Okay, so of course that's what we're going to be doing in this video. But just before we proceed, if you are new to our channel, do well to hit the like button, subscribe to our channel, and also turn on the notification icon so that whenever we release new content you actually get to know about it. And then of course, if you are a returning subscriber, do well to hit the like button too, even as we proceed. What I'm going to do is actually to rewrite this x right here. Of course, you know that x is the same thing as writing root x, okay, and then a power 2. Okay, of course, this root x is of the same thing as writing 1 over 2, x raised to power 1 over 2, then power 2, so that when you multiply this 1 over 2 by 2, these will cancel these, and then of course you are back to x. So this x, you can write it as root x power 2. Okay, so I'm going to use this to replace this, and of course as we proceed in the video you actually get to know why we are making that substitution. Okay, so if I do that, my equation now changes to root x, okay, power 2, and then raised to power this root x right here. Okay, and of course it's equal to 12. So the next thing I want to do is actually to make some substitutions so that I can find it more convenient to solve. So let's say, let me set root x to be equal to, let's say, m. Okay, so when we do that, the equation now changes to m squared. Okay, and then of course power m is equal to 12. Cool. And then of course you know that if you have a power b and then power c, you can actually write this as a power b times c. Okay, you can even decide to put this in bracket and then bring the other ones out. Okay, and of course you can also decide to write this as a power c and then power p, so whichever one you want to use. And then I'm actually going to be utilizing this right here, so that if I write this here, what I'm going to be having is m power, okay, 2m right here. 2m is equal to 12. Okay, so what we do next is actually to take the natural log of both sides so that we can be able to bring down this power 2m. So if we do that, we have the natural log of m, okay, a power 2m is equal to the natural log of 12. Okay, so utilizing the property of log, I'm going to bring down this 2m right here, so that what we have now have is 2m multiplied by natural log of m is equal to the natural log of 12. Okay, so moving on, I will divide through by this constant here too. Okay, and then this cancels this, and I'm left with m. Natural log of m, okay, is equal to the natural log of 2 divided by 2. I am going to continue to simplify this, but then of course we are going to be utilizing the Lambert W function to simplify further. And then in using that, I've actually talked about this function and its usage in most of my videos. So you will always have your expression to be in the form of a exponential a before you now apply the Lambert W function. And then once you've gotten your function to be in this way, once you apply the Lambert W function, it is actually going to give you equal to a. And so what we're going to be doing is actually to convert this, to simplify this m, a natural log of m equal to the natural log of 12 divided by 2. Okay, so we are going to be looking for a way to simplify this to be in the form of a exponential a, so that we can now apply the Lambert W function, which will help us to simplify completely. Okay, so in order to do that, I am just going to be making some substitutions, and what I'm going to do is to replace this m with exponential natural log of m. And of course, I have not done anything because exponential natural log is 1, and then 1 times m still remains m. Okay, so I'm going to replace that with this, so that now I have that this is exponential natural log of m, and then multiply by this natural log of m. Okay, and of course it's equal to the natural log of 2 divided by 2. And then at this point, you can see we've got what we're looking for. I can even decide to write this. So if I bring this on this side, I now have natural log of m, and then exponential natural log of m is equal to the natural log of 12 divided by 2. Okay, so you can see I've got this side to be in the form of a exponential a. Okay, so the next thing we want to do is now to apply the Lambert W function. And of course, when we do that, we're going to be having the Lambert W function of natural log of m exponential natural log of m. Okay, is equal to, we also do same here, Lambert W function of natural log of 12 divided by 2. Okay, so at this point, this left hand side now collapses to the natural log of m, which will be equal to the Lambert W function of the natural log of 12 divided by 2. Okay, so in order for me to get m, I am going to take the exponential of both sides. And if I do that, what I'm going to be having is exponential natural log of m is equal to exponential Lambert W function of the natural log of 12 divided by 2. Okay, so exponential natural log is equal to 1. 1 times m is equal to m. And of course, m is now equal to exponential Lambert W function of the natural log of 12 divided by 2. Okay, and of course, don't forget, we actually set our m to be equal to the square root of x, or even x power 1 over 2. So I'm going to be making this substitution back here so that I can be able to find out the value of x. And so if I do that, this m changes to x power 1 over 2, which will be equal to exponential Lambert W function of natural log of 12 divided by 2. Okay, so in order for me to eliminate this half right here, this power half, I'm going to be taking the square of both sides. Okay, so that these 2 now cancels this half, and then x is equal to, so let me put this exponential Lambert W function of natural log of 12, then of course divided by 2. Okay, all squared. And then of course, utilizing the property we used earlier, we can bring in these 2 right here, and if we do that, x now changes to exponential 2 multiplied by the Lambert W function of natural log of 12 divided by 2. Okay, and of course, this is the value of x which we are looking for. And then of course, when you compute this, you can also find an approximate decimal value for x. And then of course, if you compute this in from alpha.com, you're going to be seeing that your x will be equal to 3.6. This is just an approximate value. There are a whole lot of values for x, but this is just an approximate value of x, so that if you're not comfortable with this, you can actually also utilize this one. So this is how you solve for this kind of problems. And of course, if you've gotten some values in the video, don't forget to subscribe to our channel, turn on the notification icon, like this video, and I'm gonna see you guys in my next video. Bye.